You?
I'm fine, sir. How are you?
Yeah, fine, ma. So his physics class is little bit late, ma. So, right, ma. I don't know, sir, whether they are going to be joined or not. In last class, we were discussing about the stability of the carbene ion, stability of the carbocation, stability of the free radicals we had seen. Okay. Next, we'll see acidity of acidity of acidity of alcohols, acidity of alcohols and carboxylic acids and carboxylic acids. Okay, so now we are going to see about here acidity of alcohols and carboxylic acid. So what is the functional group of the alcohols, ma? Acid, Aditi?
Sir, OH.
OH. And what is the functional group of the carboxylic acids?
COOH.
Okay, COOH. So functional group of alcohols is equal to OH and carboxylic acids functional group is COOH. Okay. Now let us see in the both the cases how we can explain the acidity of the alcohols and carboxylic acids with respect to the inductive effect means point number one. Inductive effect is it explains acidity of the aliphatic alcohols and carboxylic acids. Inductive effect is it explains acidity of aliphatic alcohols and carboxylic acids. Okay. Now, for example, so here how we can explain the acidity means acidity is directly proportional to minus I groups and inversely proportional to plus I groups. So yesterday clearly I told that. So while coming to the class, just go through the what are the plus I groups and what are the minus I groups. Clearly I told that. So all of you read that one? Because if you don't know that one means it is not possible to find out the which one is the more acidic, which one is the less acidic. And I told that to learn the acidic strength also. Sorry, strength of the ligands, the strength of the plus I groups and minus I groups also.
Yes, sir.
Okay, right, man. So then if you read means then no problem. Tanish, you also read or not? Have you gone through your notes or not?
No, sir.
No, sir. Sir, actually you had to go through your notes now. Anyway, I'm uploading in app only. Whatever the notes we wrote, that I'm converting into the PDF file, and that PDF file is available in the app. You need not to copy the notes from this one here. So you can check it out, that notes. That is enough for you. Okay, Tanish?
Yes, sir.
Okay, so for tomorrow at least you can go through that one. Okay, so because of without knowing that one, it is not possible to find out the which one is more acidic, which one is the less acidic and all. Right side.
Okay.
Now let us see. So acidity is directly proportional to the minus I groups and inversely proportional to the plus I group. So before going to that one, first of all, what is mean by the acid? Anyone know? What is mean by the acid?
So something that is sour in nature.
Come again, Aditi.
So something that is sour in nature.
Okay, sour in nature. Is any other property, ma?
So it is also the substance which turns litmus paper, like blue litmus, into red litmus.
Very good, ma. So that is also one of the characteristic property of the acids here. Acids are sour in nature, okay, and which converts the blue litmus paper into red litmus paper, okay. And is any other characteristic properties which you know?
So
Actually,
its
how we can define
pH value is less than 7.
pH value is less than 7. If it is the pH value is 7 means it becomes as a neutral. Okay. Actually, one more definition which we can give means here what is meant with the acid? So that we are going to study in 11th standard. Actually, in 11th standard, we have a chemical equilibrium, one chapter is there. There we are going to study about the acid and bases. Okay. So according to that one, what is meant by the acids means the substance which releases the H plus ions is called as an acid. Okay. The substance which releases the H plus ions is called as an acid. So we have a strong acids and weak acids also it is there. So what is meant by the strong acid means the substance which it releases the complete, that means the substance which it undergoes to the complete dissociation.
Dissociation.
Strong acid here. What are the examples of the strong acids? Examples of,
Sulfuric acid,
very
HCl.
good, ma. HCl, HNO3, okay, HNO3, HCl, H2SO4, all these are the mineral acids. Okay, so when you dissolve in a water, they undergoes to the complete dissociation. So that's why we are calling as a strong acids. So at the same time, acidity is depends upon the liberation of the H plus ions. Acidity is depends upon here liberation of the H plus ion, and which we can call as a weak acids.
Sir, COOH,
Very good, ma.
carboxylic acid.
Carboxylic acids. Okay, next. Acetic acid. What is the best example for the, so weak acid means acetic acid is one of the best example for the weak acid, and formic acid also is one of the best example of the weak acid. Benzoic
Sir,
acid also.
all the natural acids which we find, like citrus acid and all those.
Yes, my dear. So all those are the weak acids here. Okay, so they undergoes the partial dissociation. So that means acidity is depends upon the liberation of the H plus ion. So that concept we are applying here. Okay, as per whatever you are telling, that acids are nothing but the substance which releases the H plus ion. Based on the release,
It's based on Arrhenius theory, right?
yes, ma'am. Based on it is Arrhenius theory. Okay, so based on Arrhenius theory. So based on that only, here also we are explaining which one is the strong acid, which one is the strong base and all. Actually, alcohols also they act as a acidic nature. Alcohols also they are in acidic nature. Sir, why the alcohols are they act as acidic in nature means because of they have a tendency to release the H plus ions. When they releases the H plus ions, means they also act as a acids. But if you compare with the carboxylic acids, means here alcohols are the weak acids while comparing with the carboxylic acids. Okay, so what is the best example for that one means here? Simple example one. Here, first I'll write as here CH3COOH. Acetic acid only I'm taking. CH3COOH I'm taking. Okay, better I'll take another example. Take the another example, and here also CH3 bond CH2 bond OH. In this one, which one is the alcohol and which one is the carboxylic acid, ma?
So the first one is carboxylic acid and the second one is alcohol.
Very good, ma. So first one is the carboxylic acid and second one is the alcohol, ethanol. So if you compare these two, so which one is the more acidic means carboxylic acids are more acidic in nature. Sir, how you are telling that carboxylic acids are more acidic in nature means here C double bond O group is called as an electron withdrawing group. So last time I told that carbonyl group C double bond O group is here electron withdrawing group. Electron withdrawing groups are electron withdrawing group is that is nothing but minus I groups only na. So minus I groups are they increases the acidity. Okay, in this one if you see means the OH attached carbon is attaches with the methyl group. Methyl group is the electron donating group. Electron donating groups are they increases the electron density on the oxygen atom. Okay, they increases the electron density on the oxygen atom. If the electron density is increases means OH bond it does not cleaves that much of easily. More energy is required to break the bond between the oxygen and hydrogen atom. But in this one easily we can remove the hydrogen. Sir, how you are telling that easily we can remove the hydrogen means here if you write the clear structure carboxylic acid C double bond O bond H it is there. In carboxylic acid on oxygen atom we have a two lone pair of electrons. How many lone pair of electrons are there? 2 lone pair of electrons. At the same time, in alcohol also, we have a 2 lone pair of electrons on the oxygen atom. Okay, here H it is there. Due to the presence of the electron withdrawing group, when these pi electrons are shifted on the oxygen atom, oxygen get as a negative charge. This carbon get as a positive charge. That time, the double bond is formed between the oxygen and carbon atom. So then it becomes as an electron deficient. Electron density is decreases. If the electron density is decreases means we can remove the H plus ions easily. But here is any possibility is that to remove the H plus ions easily, sir?
No, sir.
No. So because of on behalf of decreasing of the electron density, methyl group is again it is donating the electrons. If it is donates the electrons means electron density is going to be increases. If the electron density is going to be increases means attraction forces between the oxygen and hydrogen is going to be increases. So more energy is required to break the bond between the oxygen and hydrogen. So that's why so carboxylic acids are more acidic than that of the alcohols. Now you got the clarity? Okay. Again, in alcohols only. So we are going to explain the acidity. Sir, how we can explain means based on the concept. What is the concept here? Acidity is directly proportional to minus I groups. Okay. And inversely proportional to the plus I groups. So for that one, we'll see some of the example. So what are the examples means? For example, CH3 bond OH, okay, and CH3 bond CH2 OH, okay, and here if we compare in these two, methanol and ethanol, it is there. So which one is the more acidic?
Sir, methanol, because it only has like one alkyl group.
Very good. So it is attached with the only one alkali group. So methanol is more acidic than that of here ethanol. Okay, and one more example I'm giving here. So for example, CH3 bond CH2 bond OH and CH3 bond CH bond NO2 bond OH. In these two, which one is the more acidic?
So the second one, because it has an electron withdrawing group.
Okay, Sirisha. Right. So which one is more acidic, ma?
So the second one, because it has an
Second.
electron
So why the
withdrawing
second one is the more acidic in nature?
So because it
Because of
has a electron withdrawing group.
very good Aditi. Okay, so second one is attaches with the electron withdrawing group. Okay, if the electron number of electron withdrawing groups are increases, their acidic strength also is going to be increases. So first one it is attaches only with electron donating group, but second one is containing the electron withdrawing group also. Okay, and here one more condition is there, ma. So what is the another condition means the distance between minus I group and functional group increases, acidity is decreases. So now you got the concept here. What I'm telling that if the distance between the minus I group and functional group is going to be increases, acidity is going to be decreases. So now you got the clarity here. So based on that one, we'll see some of the examples. So what is the examples means? For example, if I wrote like this here. Okay. So butanol I wrote here. One butanol it is there. Okay. In that one butanol, nitro group is at present at second carbon atom. And I'm going to draw the one more structure here. Okay. Here also butanol only. But if the nitro group is present at third carbon atom. Okay.
So the
And
first one
also,
is more acidic.
okay. So what is the in this one NO2? In this one it becomes as a OH. See here I had given three structures. Okay. So can you write the decreasing order of the acidity, ma?
So the last one is the least acidic and the first one is the most acidic.
Very good, ma. So first one is the more acidic. After that, second one. After that, the last one. So why the third one, last one is the weak acidic means the distance between the OH group and nitro group is going to be increases. If the nitro group is act as an electron withdrawing group, the distance between the electron withdrawing group and functional group is going to be increases, means acidic strength also is going to be decreases. So now you got the clarity. Can I give one more example here? Okay, I'll give one more example. What is another example I can give here? And I'll give one more example. Huh? So not this one here. Okay, based on this one also I can give one more example. Yeah. Cyclo. Oh, wait. Here I can write as a CH4 group. One more I can write. Also meta position. CH4 group. Oh, CH4. Sir, which one is the more acidic in this one? Which one is more
So
acidic?
the first one.
So first one is the more acidic. Why the first one is the more acidic, ma? Why not the second and third?
So because it has the least distance.
Very good, ma. So because of CH4 is the electron withdrawing group. If you see the first structure, second structure, and third structure means the distance between the functional group and electron withdrawing groups are going to be increases. So due to that reason only last one is it becomes as a weak acid. Okay, and one more condition. There is another condition means here number of electron withdrawing groups are increases. Okay, number of electron withdrawing groups are increases. The acidic strength also is going to be increases. Sir, what is that example means? For example, CH CH F CH2F bond CH2OH CH F2 bond CH2OH bond CF3 bond CH2OH. So which one is more acidic in nature? Fluoroethanol, difluoroethanol, trifluoroethanol it is there. Sirisha, which one is the more acidic in nature? Condition is number of electron withdrawing groups are increases. Their acidic strength is going to be increases. Tanishq, Sirisha. Tanishq, which one is the more acidic in nature in the example? Either first one or second one or third one. Tanishq, I'm not getting your voice.
Sir,
The first one, second one, or third one?
So is it the third one?
So the third one is the correct answer, Aditi. Okay. Aditi, why the third one is the more acidic?
So because it has more fluorine atoms.
Very good. Actually, fluorine is it act as an electron withdrawing group. What is the condition means? The number of electron withdrawing groups are increases. Their acidic strength also is going to be increases. So due to that is only if you observe means first structure it is having only one fluorine atom. Second one is having the two fluorine atoms. Third structure is having three fluorine atoms. So number of fluorine atoms are increases. Their acidic strength also is going to be increases. And one more example I'll give for you. Number of examples I am giving. Next week you have a test based on the electron displacement reactions for next Sunday, not this Sunday. So this Sunday you're having only exam based on the reagents and attacking reagents and reaction intermediates. Okay, now I'm giving one question. CH3 bond, CH bond, OH bond, F it is there, and CH3 bond, CH bond, Cl bond OH it is there, and CH3 bond, CH bond Br OH it is there. And in these three, which one is more acidic? How we are telling that which one is the more acidic? Sirisha, Sai
So the
Akshi.
first one is more acidic.
How we are telling that first one is the more acidic, Aditi?
So because comparatively, fluorine is the most electronegative atom and it pulls the electron towards itself.
Very good, ma. Okay. So fluorine is the more electron withdrawing group, strong electron withdrawing group while comparing with the chlorine and bromine. Okay. So strong electron withdrawing group means it decreases the electron density on the oxygen atom. That's fine. So fluorine is more acidic than after that chlorine, after that bromine is the more acidic. Sir, how you are telling that means based on minus I effect. If you see the minus effect, which one is the strong electron withdrawing group means fluorine is the strong electron withdrawing group than chlorine. Chlorine is strong electron withdrawing group than bromine. Bromine is strong electron withdrawing group than iodine. Okay, so these kind of questions also they're asking the examination, increasing order or decreasing order. Same concepts we are applying for so carboxylic acids also. Okay, shall we see some of the examples based on the carboxylic acids? Now, let us see. Until here, all of you understood now? Ganesh, Sirisha, what are the conditions we wrote? Everything you understood or not? Sai Akshit. Ganesh, do you understand or not?
Understood, sir.
Yes, sir.
Yes, sir.
Okay. Now, let us see, Sirisha. I'm giving the some of the examples which is related to the carboxylic acid. So, but concepts are same only. For alcohols and carboxylic acids also we are taking as a concept is same. Okay. Now we'll see the acidity of the carboxylic acids. Okay. Carboxylic acids. Okay. Now first I'll write as a H, COOH, and differently I'll write. I don't want to write increasing order, zigzag manner. I'm going to be write like now. Here, bond COOH. Yes. CH3. Which one is the more acidic? That is my question. Three structures I had given. 1, 2, 3 I had given, sir. Which
So
one
the
is
the first one is more acidic because it doesn't have any alkyl groups.
It doesn't have
Like-
any alkyl group.
Like it has H, but like it has the least number of alkyl groups.
Okay. Then if you compare the second one, Aditi,
It
why not the
has,
second one is the more acidic while comparing with the formic acid?
so because it has more number of CH groups, like CH2 groups, right?
Aditi, here, so while writing the minus I groups, C6H5 we wrote. Did you remember? C6H5 and the least priority I had given to the hydrogen. In this one, C6H5 is nothing but phenyl group only, that means benzene ring only. Na? It is the strong electron withdrawing group than that of the hydrogen. Aditi, you got my point or not?
Yes, sir.
Okay, so C6H5 is the strong electron withdrawing group means if you compare the benzoic acid and formic acid, which one is the more acidic, Aditi, as per that one?
Benzoic acid.
Very good, Aditi. So benzoic acid is the more acidic. Now, after that, we have two conditions. Both are the aliphatic acids. So one is the formic acid is there, another one is the acetic acid is there. In these two, which one is the more acidic, Aditi?
The third one?
No. In these two, first one and third one, once you checked out, you can observe the structures. Here also COOH it is there, and here also COOH it is there. But this one, carbon is attaches with the hydrogen, and this one, carbon is attaches with the CH3. CH3 is the electron donating group.
Sir, is this the order 2, 1, and 3?
2, 1, 3 is the correct answer, Aditi. 2, 1, 3 is the correct order. So that's why I gave us a zigzag manner. So because of every time I'm writing as some increasing order or decreasing order. So this time I gave us a zigzag order. So why means we have to know. Okay, so what is the correct answer? Because of we have to apply the concepts. If you apply the concept means definitely you'll get the answer. Okay, if you observe clearly means everywhere carboxylic acid group only it is there. But at the same time, if you observe means we have a 2 electron withdrawing groups. One is the electron donating group. CH3 group is the electron donating group. But benzene ring and hydrogen we can consider it as a electron withdrawing groups. Okay, in that also which one is the strong electron withdrawing group means C6H5 is strong electron withdrawing group while comparing with the hydrogen. So that's why benzoic acid is more acidic than that of the formic acid. Formic acid is more acidic than that of acetic acid. One more example. So it look like this one only here. One more example I'll take. Sirisha, which one is more acidic? So three structures I wrote now. So structure 1, structure 2, structure 3. So which one is the more acidic? Can have 3 this one. Any one of you.
Third one.
So third one is more acidic.
Very good, Sirisha. So third one is the more acidic. So because of NF3 plus is the strong electron withdrawing group. So third one is the more acidic. After that, after the third one, which one is the more acidic? Nitropropanoic acid and cyanopropanoic acid is there. In the two first and second structures, which one is the more acidic?
Sir, is it nitro?
Very good, ma. It is nitro is the more acidic. 3, 1, 2 is the answer. So because of strength of ligand. So I explained the questions based on here strength of the electron withdrawing group. If we see means strength means which one is the strong electron withdrawing group means NF3 is the strong electron withdrawing group. Electron withdrawing groups are increases the acidity of the carboxylic acids. Okay. Now NF3 is strong acid, strong electron withdrawing group. After that nitro. After that cyano group. Okay. So now you got the clarity. And I'll give one more example. Let's see. One more question, Sirisha. Very good, Sirisha. One more question for you. CH 3 bond, CH2 bond, CH bond, and CO OH. So which one is more acidic, ma?
So first one, chlorine.
So first one and the least acidic is iodine.
Okay. So first one is the more acidic. After that chlorine. After that bromine. Least one is iodine. Now in these two structures, trifluoroacetic acid and trichloroacetic acid. Which one is the more acidic?
So the first one.
Is the first one. So why the first one is the more acidic?
Because fluorine is more electronegative than chlorine.
More electronegative than that of the chlorine. So that's why first one is the more acidic. And one more slide here. I'm going to change now. Any one of you. Which one is more acidic? I give two structures. Tanishq, Sirisha, Aditi. I give two structures.
So the second one, because it has an electron withdrawing group.
CHO group is the electron withdrawing group. So why not the first one, ma?
So because there is an alkyl group which is electron releasing group.
Very good, Aditi. Okay, so now if you see means first one and second one is the more acidic in nature. So because of here methyl group is there. So methyl group is it act as an electron donating groups. Electron donating group part decreases acidic strength. Electron withdrawing groups are the increases the acidic strength. So now you got the clarity. And one more example, ma. What is another example means here? So last one, CH3 bond, CH2 bond, CO, OH, CH3 bond, CH bond, CH3, COOH, and CH bond, bond CH3, bond CH3, COOH. So which one is more acidic?
So the first one, because it has the least number of alkyl groups.
Very good. Number of electron donating groups are decreases, exactly inversely proportional. Number of electron donating groups are decreases. Their acidic strength also is going to be increases. First one we have a zero electron donating groups, but second one we have a one methyl group, and third one if you see means two methyl groups are there. Number of electron donating groups are increases. The acidic strength also is going to be decreases. So now you got the clarity. Can I give one more example? One more example in different formation. Okay. So this is another example I can give here. For example, which one is more acidic? I give four structures here. Tanishq,
So the last one is most acidic.
the last one is
More acidic.
more acidic. Why the last one is the more acidic, Aditi?
Because it has more electron withdrawing groups.
Okay, Aditi, can you tell me the decreasing order of the acidic strength?
Sir, fourth one, third one, first one, second one.
Fourth one,
Third one,
third one,
first one, second one.
first one, and second one. So anyone you are having doubt in this one regarding this part? Do you have any doubts in this one, ma? Sirisha,
No, sir.
Tanish, I gave so many examples. Just go through the notes and make practice, ma. Then only you can understand. Okay. So in the next class, we will discuss about the mesomeric effect. Okay. Yeah. So we'll continue in the next class. Thank you all.
Thank you, sir.